Okay, so I already started this one, so for you guys that are at home, the first thing you want to do on this problem is you want to get the square root all by itself if you can. So we divided both sides by 2. So now we have the square root of the quantity x plus 1 equals 7. And then you cannot solve for x when it's stuck inside of that radical. So how do you get rid of that square root? What's the opposite of square rooting?
Squaring?
Yeah, the inverse operation for square root would be to square. You guys remember that the index of this root right here, there's a little 2 right here, right? When there's nothing written there, it's implied that it's a 2. So the opposite of square rooting is to square. So we are going to square both sides. So we're going to square the left side, and then we're going to square the right side. Well, then the square and the square root, they undo each other. So all you get on the left-hand side now is that quantity x plus 1 will come out of the square root. And on the right-hand side, you've got 7 squared, that's 49. And then you just subtract 1 on both sides, and you get x equals 48. Now, the only thing on these is you should, or I shouldn't say you should, you need to check your answers on these. So whenever you square both sides or raise both sides to a power, you need to check your solutions and make sure they work, because sometimes they won't. If you get a solution that doesn't work, that's called an extraneous solution. So let's check this one real quick. You guys could check them just mentally, or you could check them on your calculator or your phone if you want to. But basically, we're going to plug 48 into the original problem. So you don't have to write this part down. I'll just write it real quick. So we're going to plug 48 in for x in the original equation. So that would look like 2 times the square root of, and then we'll put the 48 in for the x. And then plus 1, and then that should equal 14. And you guys should see that that works, right? If you do 48 plus 1, that's 49. The square root of 49 would be 7. And then 7 times the 2 would give you 14. So it checks. So this solution is, that's a good solution right there. All right, 4 more to go. So the next one, we're going to do example 1b over here on this side. So on this one, we have 5 times the cube root of the quantity 4x plus 3, and that is equal to 15. All right, so on this one, again, if we can, we like to isolate the radical, get it by itself. So how would I get rid of that 5? Yep, divide again. So we're going to divide both sides by 5. And then because of that multiplication right there, those 5s are going to cancel. All right, so now we have the cube root of the quantity 4x plus 3. And that's equal to 15 divided by 5, which is 3. Okay, well now again, we can't solve for x when it's stuck inside of the radical. So what's the opposite of cubing? Oh, I just said it backwards. I already gave you the answer. I was supposed to say, what's the opposite of the cube root? Well, the inverse operation for taking the cube root would be to cube both sides, or raise both sides to the 3rd power. So I guess I couldn't call on you guys because I gave you the answer. So we got to raise the left-hand side to the 3rd power and the right-hand side to the 3rd power. Well, then the cube root and the cube, they undo each other. So you just get the 4x plus 3 out of the radical. So you just get 4x plus 3 equals, and then on the right-hand side, you got 3 times 3 times 3, which is 27. And now you just got a nice little 2-step equation. So you subtract 3 on both sides. Those cancel out, make 0. You get 4. You get 4x equals 24. Then you divide both sides by whatever number's in front of the variable. Those cancel out, make a 1, and you get x equals 6. But again, then you're supposed to check your answer real quick. All right. So I'll do that over here on the side real fast. So into the original equation, we would have 5 times the cube root of 4 times x, and the x that we got was 6, right? And then plus 3. And then that should equal 15. So if we check that real quick, we got 4 times 6, that's 24. 24 plus 3 would be 27. Then we would do the cube root of 27. That would give us 3. So then we do the 3 times the 5 out in front, and we get 15. So that's also a good answer. So that one checks. All right, so 3 more to go. So for the next one, I think we got to turn the page here. So the next one, we're just going to do the example right here. We're going to do number 2 on page, I don't know, what is that? 629. So this one. So on this one, we've got the square root of 35x equals 5 times the square root of the quantity x plus 2. Well, this time we really can't get a radical all by itself, okay? I mean, we could divide both sides by, don't write this, we could divide both sides by 5, right? And then these 5s would cancel. But now you're stuck with this 5 over here, right? So that really doesn't do you any good. So on this one, you're going to start out, you're just going to square both sides right away. So we're going to square the left side. And then we're going to square the entire right-hand side, okay? Whatever that right-hand side is, we got to square the whole thing. So what I'm saying is I don't want you to do this. I don't want you to just square that part. You got to square the entire right-hand side, like this. Okay, well, on the left-hand side, the square and the square root undo each other. Again, you guys know that when there's nothing written here, that index in there is a 2. So the square and the square root undo each other, and we just get 35x equals. Now, when you do the right-hand side, there is a multiplication right here. Well, that means you got to square both factors in that product. So you got to square the 5 and, oh, see if I caught it in time this time. There we go. So you got to square the 5, and you got to square the square root of the quantity x plus 2. Okay? So let me write it that way so you can see. So you got to do 5 squared, and you got to do, that would be multiplied by the square root of the quantity x plus 2. That would also get squared like that. So on the left-hand side, you still got 35x. On the right-hand side, you got 5 squared, which will give you a 25. And that would be times, well, then the square and the square root will undo each other, and you'll just get the quantity x plus 2 out of the radical, but you need to make sure you put it in parentheses because it's 25 times that whole thing. The common mistake on this one would be people forget to square the 5. They forget to do this. And they would write a 5 right here instead. All right, so then we're going to distribute. So we're going to distribute the 25 here. So then that's going to give us 35x equals 25 times x would be 25x. And then plus 25 times 2 would be 50. Now we're just going to solve for x. So we're going to subtract 25 x's on both sides. That leaves me 10 x's on the left. And that's going to be equal to, these cancel out and make a 0, so that's going to equal 50. And then we're going to divide both sides by the number out in front of the variable. Those are going to cancel out and make a 1, and we get 1x equals 5. But then we do want to do the check on this one also. So let's do that over here. So the check on this one, if I can I guess I can do it down here now. So the check on this one, we got to plug in 5 into the original equation. So that's going to look like the square root of 35 times 5. That is going to have to equal the right-hand side, which would be 5 times the square root of x was, again, 5. Hold on. X was 5, and then plus 2. So this one, I think we're going to need a calculator to check it. Because underneath that radical, we're going to get, on the right-hand side, we're going to get the square root of 7. Well, the square root of 7 is some weird decimal, right? That's an irrational number. The square root of 7 is going to be a decimal number that goes on forever and never repeats. So let's see, what do we got? So on the left-hand side here, we got the square root of 35 times 5. That is, what is that? That is 175. And on the right-hand side, we got 5 times the square root of 5 plus 2 is 7. So we got to make sure that those are the same. Now, if you're good at simplifying your square roots, you could probably break down the square root of 175. I'll just tell you what you would do verbally. You would rewrite the 175 as 25 times 5. No, wait a minute, 25 times 7. Is that right? Yeah. So you would rewrite the 175 here as 25 times 7. And then the square root of 25 would come out in front as the 5. So it would check that way. But I'm just going to check it on my calculator. So if I do the square root of 175, I get, it's going to be a round off. It's approximately 13.23. So this is approximately 13.23. And then that should equal the other side. The other side, I'll do the square root of 7 on my calculator, and then multiply that by 5, and I still get approximately 13.23. So that's approximately 13.23. So that's just checking it on the calculator. So that solution is also good. How many have we done now? 3? We got 2 more to go. All right, so let's see, what do we got? Are we going to do this one? I think so. So let's do this one over here. Or maybe I can do it down here. All right, so this one, we have got the square root of the quantity x plus 18 is equal to the quantity x minus 2. Well, the radical is already by itself, so we're just going to undo the square root, so we're going to square both sides. So we're going to square the left side. And now when we square the right side, we have to square that entire right side, okay? So square whatever's on the right-hand side like that. Well, on the right-hand side now, we have the quantity x minus 2 squared. So let's go over here on the side and review how do we deal with that. So if you have x minus 2 quantity squared, so x minus 2 squared, you guys know that that means the quantity x minus 2 times itself, right? So you have to be able to multiply that out correctly. So in the blue here, we're going to distribute this x onto both of these terms. And then in the green, we're going to distribute this negative 2 onto both of these terms. So in the blue, we would have x times x, that's x squared. And then also in the blue, we'd have x times a negative 2, which would give me negative 2x. And then in the green, I would have the negative right here. I would have the negative 2 times the positive x. So that would give me negative 2x. And then also in the green there, I would have negative 2 times negative 2, which is a positive 4. Okay, so what you should get out of that is you should see that now these combine in the middle right here. So we've got an x squared. In the middle there, we've got negative 2x, take away 2 more x's. That's negative 4x's, and plus 4. So that's what we should have on the right-hand side. Now the common error here is a lot of people look at this, they forget how to square this thing. So what a lot of people do is they'll go, let's see, they'll square the x. So they'll square this, and they'll write x squared, and then they will square the negative 2. So negative 2 times negative 2, they'll do that, and they'll say, oh, that's a positive 4. But notice then they forgot the term in the middle, right? That would be the common error. And if you look down here, the term in the middle was supposed to be a negative 4x. So there's supposed to be a negative 4x in here, right here. All right, well then over there on the left-hand side, that's not too bad, right? The square and the square root will undo each other, and we just get the quantity x plus 18. And now we have to try to solve that for x. Well, anytime you have 2 different powers of x, like in this one, we have a x squared and a x to the first. Anytime that happens, you're going to have to set it equal to 0 to solve it. I don't care if it's got an x to the third and an x to the first, or if it's got an x to the fifth and an x to the fourth. Anytime you have 2 different powers of x, the only way to solve it is by setting it equal to 0. So we need to get this thing equal to 0, so let's do this all at once here. Let's subtract 18 on both sides. And also let's subtract x on both sides. Well, then over here on the left-hand side, these cancel out. So now the left-hand side is just 0. And that equals x squared. Then we got negative 4x, take away another x. That would be negative 5x. And then we've got a positive 4, take away 18. That would be a negative 14. Well, now we got to solve this thing. So that's a quadratic equation, and we've been lucky that in chapter 8, every single one of these we've had has been able to we've been able to factor it, right? We never had to use the quadratic formula, or a quadratic equation to solve it. I should say the quadratic formula. But like I said, way back in the first week of the semester, you got to be able to factor in chapter 8, or you can't do this stuff. So we got to know how to factor this. So we need 2 numbers that multiply to negative 14, where the same 2 numbers add up to negative 5. So who's got that?
Negative 7 and 2.
Good. So we've got a negative 7 and a positive 2. So if we multiply these 2 together,
Hang us up.
oh, let's see if I can get it quick enough. Nope. I hate when that happens. Uh-oh, I think I just typed my password in wrong. Hold on. You guys at home? I got computer difficulties here, so hold on a second. That's what I hate about this thing. You type the password in wrong and then you gotta wait all that time. All right, let me make sure I type it in right. What does it say? Caps lock is on or something? I don't know. Is it on? I can't tell. There, okay, let's try this. There we go. All right, so anyways, we were checking this. We've got -7 times +2. That would give us -14. And then we got a -7 plus 2, which would give us this -5 on that middle term right there. Okay, so now we've got a product of two factors set equal to 0. So we got to set each factor equal to 0 and solve. So we're going to set x minus 7 equal to 0, and we're going to set x plus 2 equal to 0. Then we're going to solve both of these. So we're going to add 7 on both sides here. We're going to get x equals 7. This one we're going to subtract 2 on both sides, and we're going to get x equals -2. But just like before, I said you got to check these in the original problem and see if they work or not. So let's do that down here. So what is the original? Okay. So in the original, we would have, let's see, we had the square root of, what was it? X plus 18. So let's plug the 7 in. So 7 plus 18. And then that was supposed to equal x minus 2. So we're plugging in the 7. So that should equal 7 minus 2. So if we try that, let's see, 7 plus 18, that's 25. The square root of 25 is 5. So this side is 5. And 7 minus 2 on the right-hand side, that's also 5. So this one's good. Now we quickly want to check the other one. So let's see if I could just do this. Let's see. Let's erase that. Erase that. Actually, I want that to be in. All right, so this one we got to put in the -2. So we're going to plug in the -2 for x. So we're going to put a -2 right here. And right there. So we just plugged -2 in for x. So on the left-hand side, we got -2 plus 18, that's 16. The square root of 16 is 4. So this side is 4. And the right-hand side, we got -2 take away, again, we plugged in -2 for x. So the right-hand side was x minus 2, so we do -2, take away 2 more, that's a -4. Well, those are not equal, right? So if those are not equal, that means that this solution was no good. So you only have one, that x equals -2, that's called an extraneous solution. So the only solution is x equals 7. All right, one more. I think that was it for that page. So last one. So here's the last one. This one says the quantity 3x minus 1 to the 1/5 power equals 2. So for this one, they're back to the fraction exponent stuff. That's what we did on, we did that on Friday. So you guys were remote. So I'll do a quick review on the side over here. So when you're doing fraction exponents, maybe I'll do it down here at the bottom. Like if you have something like a to the 2/5 power or something like that. If you want to rewrite that in radical form, you can write that as the 5th root of a squared, like that, or you can write it as the 5th root of a squared, like that. I generally prefer that I do it this way. Okay, but the important idea in that is to remember that this denominator of your rational exponent, the denominator of your fraction power, that is the same as the index of your root. So it goes in there or in there. Again, that number right there, that's called your index. All right. So that's what we're going to do. We're just going to take this original problem for our last example, and we're going to rewrite it in radical form. Okay, so we're going to take it from, or we're going to write it with a root instead. So we're going to take it from rational exponent to radical form. So let's do that. So using that idea that I just showed you, I'm going to make this the fifth root. So I'll make that the fifth root of the quantity 3x minus 1, that whole thing to the first power. Well, if it's to the first power, I don't need that there, right? So basically, if it's a 1/5 exponent, it's the same thing as the fifth root. So since that's to the first power, I'm just going to write this as the fifth root of the quantity 3x minus 1. Okay, well now we got to get the x out from underneath the radical. So how do we get rid of the fifth root? So how do you undo that, guys? How do you get rid of the fifth root? What's that?
It's like a square.
Yeah. So instead of squaring both sides, you're going to raise both sides to the fifth power. So you're going to take the left-hand side and raise it to the fifth power, and the right-hand side and raise it to the fifth power. And then on the left-hand side, the fifth root and the fifth power are going to undo each other. Those are inverse operations. So you're just going to get the quantity 3x plus or 3x minus 1 out of the radical. And on the right-hand side, you got 2 to the fifth power. So that's 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And then you're just going to solve this equation. So we're going to add 1 on both sides. And we're going to get 3x equals 33. And then we're going to divide both sides by whatever number's in front of that variable, and we're going to get 1x equals 11. But then we are supposed to check this. I'll check it from like right here. Because the 1/5 power is the same thing as the fifth root. So I'm going to do the fifth root of, I'm going to plug in the 11. So it's going to be 3 times, I'm plugging in 11 for x, minus 1. That is supposed to equal 2. So really, I guess I should say, that's the same as plugging it into this one right here. Again, because the 1/5 power is the same thing as the fifth root. So anyways, inside of there then, I've got 3 times 11, that's 33, minus 1. That would give me 32. And then the fifth root of 32, well, that says what number to the fifth power equals 32? The answer to that is 2. So that one checks. So that solution is good. All right, and I think that'll do it. So a lot shorter lesson. Hopefully you guys thought that was a little more straightforward than what we were doing. And I'm going to write down your assignment on here for you. So that was the last section in chapter 8. So let's do some of these fun problems. All right, so we're going to do the assignment on page 632. So it's on page 632. Let's do 2 through 22, the evens. But then also let me give you some of the odd ones because I like you to be able to check them in the back of the book. So let's do 27 through 41 odd. If I could write. I don't know what happened to me here. I can't write at the end of this. There we go.